So hello guys, once again I welcome you all of you in this marathon session, or you say previous year questions session. Today we're gonna discuss about previous year questions of railway engineering and airport engineering of gate examination. Okay, so yeah, let's start. So basically, railway engineering and airport engineering adds in 2017 in gate examination. Before that, there is no question of railway engineering and airport engineering in gate examination. So we have only questions from 2017. Okay, so let's discuss it. So first question. So our first question is from gate 2017 1 mark question. So what in this, that a runway is being constructed in a new airport as per International Civil Aviation Organization ICAO recommendation. The elevation and the airport reference temperature, that is ART, this is 22.65 degrees Celsius. That is, it is given that our ART is equal to 22.65 degrees Celsius. Okay, uh, and here also the elevation, and our elevation given is that 535 meter above the mean sea level. Consider the effective gradient runway as 1%. Effective gradient is given 1%. The length of runway required for design aircraft under standard condition is 2000 meter. Basically, it is BRLR, basic runway length. It is given 2000 meter. Within the framework, the applying sequential correction as per the ICAO recommendation, the length of runway corrected for the temperature. We need to find the length of runway corrected for the temperature only. Okay, and we have this data given in this one. Let's add a page and solve this question. So we have ART is equal to 22.65 degrees Celsius as it given here, and our elevation is equal to 535. Elevation is equal to 535, 535, and our effective gradient 1% and BRL 2000 meter. Effective gradient 1% and BRL 2000 meter. Okay, 1000 meter. So yeah, this thing is given in the questions, and we need to find the length of runway corrected for the temperature. So our first correction is, as if you remember the correction that in BRL, that there is increase of 300 meter in 7%. Okay, 7% increase per 300 meter. Okay, if you remember that correction for elevation, that there is increase of 7% per 300 meter. So here for 1 meter it's about 7 by 100 into 300 meter, and for this is basically, this is correction for elevation. Correction for elevation, 1 meter for 7 by 100 into 300. So for 535 meter, it will be 7 by 100 into 300 into 535 meter. So if we calculate this, we'll get a value that 7 multiplied with 535 meter divided by 100 then divided by 300. You will get value of 0.12483333. Okay, and here we multiply our length, which is BRL, that is 2000 meter. So multiply it with 2000 and we'll get a value of 249.6. We'll get a value of 249.67 meter. So total corrected length from elevation. So total 2000 plus 249.67. So add it with 2000, we'll get a value. Give me a second. Then we'll get a value of 2249.67. Okay, so this is what value, this is the corrected value after elevation. What we get, 2249.67. So our next correction is correction for temperature. So this is correction for elevation, and our next correction is correction for temperature. So now we go with correction for temperature by using these given values. Okay, we have a ART of 22.65 degrees Celsius, and here we need to find standard temperature. So standard temperature, we have formula for that, 15 degrees Celsius minus 0.0065 multiply with elevation, which is 535. Okay, this is our so if we calculate this, so this will be equal to 0.0065 multiplied with 0.0065 multiplied with 535. It is 3.4775. Subtract it from 15, you'll get 11.5225 degrees Celsius, and we'll get change in temperature where ART minus this standard temperature, or you say corrected temperature, or you say correction of temperature. Of temperature. So we have ART of 22.65 degrees Celsius, and subtracted from to 11.5, you see 11.5225 degrees Celsius. If we subtract it from 22.65, we'll get a value 22.65 minus 11.5225. We'll get value of 11.1275. Give me a second. Yeah, we'll get value of 11.1275 degrees Celsius. Okay, this is correction of temperature. And after that, we'll after that, we need to find corrected length due to temperature. Corrected length, corrected temperature length, or you say corrected temperature length. So for this, we have before that, let's see, is this one more thing before that, let's see, is it, let's check, is it exceed this temperature to 35 or not. So for that, we'll see it a little. Let's find corrected temperature first. So corrected corrected temperature length. Okay, so for that we need to do we need to do our we need to find what our previous value, that is 2249.67. So 2249.67 divided by 100 multiply by this value 11 point, you say 13. Okay, if you multiply it with this you'll get a value of, so multiply it with 2249.67 multiplied by 13, sorry, multiplied by 11.13 divided by 100, we'll get value of 250.38. So total correction is equal to 2249.67 plus 250.38. So added with 2249.67, so it is something about 2500.05. So it is equal to 2500.05827. Okay. Oh, so this is our corrected value of corrected temperature length 2500.05. Let's say, is there any option in given? So yeah, option C is our correct answer. So this is question from gate 2017 1 mark question, which from set 1. Let's see our another question that this is a basic formula wise question that for broad gauge railway track on a horizontal curve radius r, equilibrium constant E required for train moving of speed v. So if you remember that we have a formula that gv square upon 127 r, and for broad gauge g is equal to something 1676 around, you know. So if we divide e is equal to 1676 v square by 127 r, so divided by 1676 to 127, so 1676 divided by 127 will get, it is around 13.19 v square by r, and by change its c unit we will say this one is b option is correct answer. Okay, and here we need to change some units, so you'll get answer. This is also from gate 2017 1 mark question, and it is from set 2. And our another question from gate 2019, that a broad gauge railway line passing through a horizontal curved section having radius 875 meter of length 200 meter. Allowable speed of this portion is 100 km per hour. For calculating the can't, consider the gauge as center to center distance between the railhead is equal to 1750 mm. The maximum permissible can't in mm round of one decimal place with respect to center distance between the rail heads is okay. So we have there is a given radius is equal to 875 meter, and our length is equal to 200 meter, and there is a velocity of 100 kilometer per hour, and our center to center our gauge given 1750 mm, and we need to calculate maximum permissible current, that is cm. And you know, if you see my previous video of if you see my previous video of railway engineering, sorry, if you see my previous video of railway engineering, you'll get the value of cm, which is maximum permissible can, that it is equal to gv square by 127 r. So put this value and you'll get the answer. So g is equal to 1750 into V 100 square. Wait a second. 100 square upon 127 into radius. What radius given? 875. So 875. Do this calculation, you'll get the answer. So 1750 into 100 into 100 and divided by 127, then divided by 875, we'll get answer of around one. Here we need to do something, that this is in mm and this is in kilometer per hour, and with, so wait a second, we need to add and subtract something. So basically change it all in meters, change all in meter. So if you change this in meter, 10 to the power minus 3, and this is meter, this in meter. Okay, so wait a second. So it is about 15.74. So you'll get value of 15.74. Or if you need to change something here, so if you put all these things in meter, we'll get a value of kilometer in meter, then 10 to the power 3, then 10 to the power 3. It's about 10 to the power 6. Yeah, this in 3. So it is in kilometer also. And we need it in mm. So no problem. We need it at mm. So let's modify it in mm. So it is in mm. And we need to calculate this 100 in mm. So 100 into 10 to the power 3 in meter, it's came to about 157.3 also. 157.4. 57.4. This will be this. Okay. So this will be the right answer. Let's move on to our next question. That is the appropriate. This question is from, give me a second, of 2022 question of 2 marks. In this, the appropriate design length of clearway is calculated on the basis of normal takeoff condition. Which one of the following option correctly depicts the length of clearway? Note none of the option are drawn to scale. Okay, then. So let's see the diagrams. So we need to calculate this. These are the diagrams. Yeah. The appropriate design length of clearway is calculated on the basis of normal takeoff condition. Which one of the following option is correctly depicts the length of clearway? We need to find length of clearway. It is a normal takeoff condition. So see these diagrams. Either this one, or this one, or this one. Say this. So from normal takeoff condition, length of clearway, this is the correct answer. Okay. This is basically a theoretical question. Let's move on to next question. Basic next question of this is of 2 marks, which is a more important thing there. You need to find one thing in this diagram, and you'll usually get 2 marks. Here also it is of 2 marks of basic question. And here that look, for the hottest month of year, the proposed air site in monthly mean monthly mean average daily temperature 39 degrees Celsius, and the monthly mean of maximum daily temperature is 48 degrees Celsius for the same month of the year. So given information, from the given information, the calculated airport reference temperature is. So from the given information, you need to calculate the calculated air for reference temperature, that is ART. We need to find ART. If you remember this formula, that TA plus TM minus TA by 3. Put all these values here, you'll easily get your answer. Okay, so ART is equal to TA, this is our TA, and this is our TM. Okay, so TA 39 plus 48 minus 39 by 3. Wait a second. So here 39 by 3. So here is equal to ART is equal to 39. Shit, man. Give me a second. So ART is equal to 39 plus 48 minus 39, that is 9 by 3. So 3 is a 9, and you'll get ART is equal to 39 plus 3, that is 42. Wait a second. Okay, and in previous question where we need to, that is 42 degrees Celsius, say this one. Okay, so this is all about previous year questions of railway engineering and airport engineering, and this is it. Actually, airport engineering and railway engineering is added in was added in 2017 in gate examination. Before that, these chapters not in the syllabus of gate examination, so that's why we have a question from 2017 or 17 only. And this is it of previous year question of gate examination. So yeah, this is it. This is all about our previous year questions of gate examination. Okay, here this is correct answer are 157.4. If you'll do the calculation, you'll get at 157.4. Okay, this is 157.4 in okay, so this is it. This is all about our previous year questions of gate examination. So till then, do lot of more questions, do lot of practice of gate examination questions of previous year questions, and till then, take care. Goodbye. Thank you so much for watching this video. Thank you.